So on Wednesday, we started to look at slope. I remember explaining in the video from Wednesday, like if you're going skiing, there's going to be different types of elevations. There's going to be steeper mountains versus not as steep. So bunny slopes. Those are the ones you would start at when you are like a beginner. So if you're a beginner skier or snowboarder, you're going to start at the bunny slope, get your confidence level up, get your skills up, and then you can go to the more steep hills, like eventually a black diamond. So slopes are all about the change in your horizontal movement, which is like up and down, versus vertical movement, which is up and down, versus your horizontal movement, left to right. The steeper you are, the harder it would be to go up or down that slope, whether you're skiing down or walking up. And we can find slopes of lines using graphs, using tables, and using 2 points with either counting or using a formula. So we're going to actually find the slope today. I did already go over this again on Wednesday, but I do want to just kind of go over it again so you can get a little refresher with what slope is. So slope is the measurement of the steepness of a line. It is described as a constant rate. So all slopes that we are going to be finding in this section are all going to be constant. The slope will always stay the same, which is why it creates a straight line. The slope is a ratio that compares your change in your vertical distance to the change in your horizontal distance. If 2 points are given, like x1, y1, and x2, y2, you calculate the slope with this formula. Today we're actually going to go over this formula. On Wednesday we did not. I just kind of skipped over it and showed you the different types of slope. Today we will be going over how to find the slope given this formula. Slopes of lines are going to be fractions. Sometimes those fractions end up being whole numbers. Like if it ends up being like 2 over 1, then the slope could just be simplified to be just 2, since 2 over 1 is just 2. But slopes are always going to be fractions because they're ratios. Ratios are fractions, and ratios are comparing two numbers. And when you're comparing two numbers, you're looking at how far you're going up versus how far you're going over. That's your change in your vertical versus horizontal movements. I already talked about the 4 types of slopes, but just a refresher again. There's a positive slope. We read graphs from left to right, and when you read from left to right, this line's going up. This positive slope, if you were thinking about walking on it, you would be walking uphill. Positive slopes are going to be positive numbers. Negative slopes, if you're reading from left to right, it's going down. If you were walking on this line, you would be going down. And negative slopes are negative numbers. Zero slopes are flat lines, like when you're walking in the hallways at Pencrest. Unless you're on like a catwalk or something, the halls are just going to be flat. There is no incline, there's no increase or decrease. It's just 0. Undefined slopes are vertical lines like this. Vertical lines go up and down, and vertical line slopes are called undefined, and we'll really find out why today. So we already did these problems. We already graphed these points, and we maybe answered a couple of these questions, but what we didn't do was this part here, using the points of the line to find the slope with the formula. So the points that we have here are -1, -2, 0, -1, and 1, 0. So I'm just going to write this down here. The 3 points we have. -1, -2. What was the next one, Gabe? Was that one right? Sorry.
I didn't get this one.
-1, -2, 0, -1, and 1, 0. Okay. I just can't see the top, so that's why I wrote them down here. So here are the 3 points that are above here. I'm just writing them down here so that we can finish this part here. It says, use any 2 points on the line and the formula for the slope to verify the slope of this line. So you should have already filled this out from the video before, but we're skipping down to letter D where I skipped in our video from before. So you can choose any 2 points to find the slope. You only need 2 points. So if I call this point 1, this point 2, and this point 3, I could either use 1 and 2, I could use 1 and 3, or I can use 2 and 3. It does not matter which 2 points you use. You just have to pick 2 points. I'm just going to use the first two. I'm going to use -1, -2, and 0, -1. And what I'm going to do is find the actual value of the slope, which is going to represent the ratio, the comparison of the steepness of this line. The formula for slope looks very crazy. The formula here for slope is m equals y2 minus y1 divided by x2 minus x1. Now, m, this variable here, stands for slope. I'm not really sure why they use m and not maybe something like s for slope, but m does represent the slope here. And the formula, these y's, they're just showing what y values to subtract and then what x values to subtract. Since this is the first point that I wrote down, and each point is x comma y, since this is the first point, then this means this is the first x and this is the first y. So x1 technically is -1 and y1 is -2. Since this is the second point I wrote down and every point is x and y, this is the second x and this is the second y. That's where those numbers come from. So you write the 2 points down. The first point you have would be x1 and y1, since those are the first x and y. And then the second point you write down would be the second x and the second y, which is why we would call it x2 and y2. It doesn't matter the order, actually. If we flip the order, if we use different points, our process will look different, but the answer will still be the same, and I'll show you that. To find the slope, what we do is we take this formula and just follow it and put the numbers in. So the formula says take y2. Well, y2 is right here. That's -1. The formula uses subtraction, so we have to put -1 minus, and y1 is -2. Here's y1 right here. So we have to just be careful with the double negatives. And then this is all going to be divided by x2 is 0. The formula is subtraction, so it's 0 minus x1 is -1. You just have to be very careful with these little double negatives. This will happen sometimes because of the formula being subtraction. If you're ever subtracting a negative, either use your calculator, or if you know how to simplify this, at this point you should, but whenever you subtract negatives, that really means additions. This is going to turn into a plus sign. This is going to turn into a plus sign. It's not always going to do that. Sometimes it just will end up being subtraction. The only reason why it did do that was because you're subtracting a negative, which is really addition. Now we simplify the numerator and denominator separately. -1 plus 2 is 1. 0 plus 1 is 1. The slope of this line is 1 over 1. Whenever this happens and you can simplify the final answer, like 1 divided by 1, that's a fraction, yeah, but we could just simplify this to just being 1, and then that would be it. Your slope for this line is 1. And if you remember from when we did graph this, -1, -2 is right here, 0, -1 is right here, and 1, 0 is right here. So you can see those 3 points, and if we made that line here, you could see what the slope is really meaning. So if we connect the line here between these 3 points and we make the line all the way through the graph, the slope is saying how do you get from one point to the next? So if we go from this bottom point, which is -1, -2, and then we go to -0, -1, this middle point here, to get from that point to that point, you would have to go up 1 and over 1, like as if you're taking a step. Imagine going up a flight of steps. Every time you go up a step, you have to go up first before you go over. To get from this point, you go up 1, over 1, up 1, over 1. That's what this ratio is saying. Whenever you have slope, your slope really means how much you're going up or down, which is rise, versus how much you go left or right, which is run. The slope of a line it has 2 formulas. The formula is either this crazy thing, which is y2 minus y1 over x2 minus x1, or you can call it rise over run, and you can use the graph to help you count. Now, this is not the only 2 points that will give you this answer. If I erase this, and you don't have to write this, you can just follow along. if I erase this and I use different points, I will still get the same exact answer, and I want to just quickly show you that. So, instead of using the first and second point, why don't I use the second and third point? So I'm going to use 0, negative 1, and 1, 0. Now everything is changing since my numbers are changing. This is the first x, this is the first y, this is the second x, this is the second y. So this is y2. I must have did another x here. So now when I put these numbers into the formula, y2 is 0. This is going to be 0 minus y1 is negative 1 over x2 is 1 minus x1 is 0. So for this one, I just have to be careful with the top. The top has double negatives. 0 minus negative 1 is really 0 plus 1, which is 1. The bottom one you did not have to change to be a plus because 1 minus 0, there's not a double negative. 1 minus 0 is just 1. We still will get 1 over 1 as our slope, which then simplifies to just being 1. So our slope is 1, meaning that it is a positive slope. I would be able to tell that from the actual graph itself if I had a line connecting these points. Reading it from left to right, the line is increasing, so I know that this would be a positive number, and 1 is a positive number. And what that means, 1 over 1, what it means is that your rise, how much you go up, versus your run, how much you go over, is 1 to 1. So you would go up 1, over 1, up 1, over 1. It's not always going to be that case. Sometimes your slopes might be 2 over 1, which means you would go up 2 over 1, up 2 over 1 if you had a steeper line. Maybe it's not just 1 and 1 like that. Maybe it's 2 over 3. Sometimes you will go up 2 and over 3 instead of going over 1. So they're always going to change and be a little bit different depending on the problem. Oh, down here in letter E, it's asking us to use 2 different points on this line to find the formula for slope. So I actually showed you 2 ways. I showed you one, the first and second, and I showed you the second and third. What I want you guys to do is use the last 2 that we didn't to just verify this. So if you didn't copy this down, I didn't realize it was there, but if you didn't copy this down, let's try this. I'll give you a few minutes. Try this one more time. Let's use negative 1, negative 2, and 1, 0. So negative 1, negative 2, and 1, 0. Take a minute and try this on your own to verify you understand how to find slope. So use negative 1, negative 2, and 1, 0 to find the slope. Your answer should end up being 1 because this is the same exact line. But let's just verify we understand how to use the formula. All right, so we use these 2 points instead. This is the first x, so that's x1. This is the first y, this is y1. This is the second x, this is the second y. So when I use the formula, I'm going to be doing y2, which is 0, minus y1, which is negative 2, over x2 is 1, minus negative 1, here, like that. So I would have to just be very careful with the double negatives for both the numerator and denominator. 0 minus negative 2 is 0 plus 2. 1 minus negative 1 is 1 plus 1. 0 plus 2 is 2. 1 plus 1 is 2. So we get 2 over 2, which ends up equaling 1 again. So the slope is still going to be 1. Whenever you get a fraction that can be simplified, like 2 over 2, you're going to want to simplify that. All right, so in the next example here, I'm not sure if we went over this in the last video or if the video stopped after that, but now we have 3 different points here. So if I was to graph these points, -2, 3, I would go over to the left 2, and I would go up 3. So the first point would be here, and then -1, 1 would be here, and 0, -1 would be here. So if I'm looking at these points here, and I was to draw my line through them, here's what my line would look like. And I know this is just a sketch, it's not perfect. But here's the linear line and what it looks like. From looking at this picture, I could tell that this line is going to have a negative slope. Because if I look at the line's going down. So because it's going down, that means that it's a negative slope. My slope will be a negative number. Letter A is asking us to find another point on the line that contains these points. Well, I can just look at like this point right here. I can see the way the line is going. To get from one point to the next, I can see that you're going down 2 and you're going over 1. So here's another point right here that lies on this line, and that's 1, -3. So another point that lies on the line is 1, -3. And you could use any other point that you find that is on that line for that one. For this graph, as x increases, y decreases. Therefore, the slope of this line containing these points is negative. There's 2 ways to find slope. In letter C, it says identify the change in y and the change in x on the graph. That means find the slope of the line from the graph. Finding slope can be done 2 ways. You can use the graph and use the rise over the run formula. This is for a graph. Or from 2 points, you can use the formula y2 minus y1 divided by x2 minus x1. So there's 2 ways to find slope. In letter C, they want us to identify the change in y and the change in x on the graph. Using the graph, we would use the rise over the run method. To do that, you would go to the graph and you would pick a point to start out with. I usually start with the point that's all the way to the left. So I'm going to use this point right here. So this is where I'm going to start. I'm going to start at that point, and then what I like to do is pick another point to end. I'm going to use the next point right next to it. I'm going to start at -2, 3, and end at -1, 1. What I'm going to do is to get from the starting point to my ending point is first figure out my rise versus my run. So rise is how much you go up or down. Run is how much you go left or right. So when you're rising, you probably think you're going up. But sometimes you end up going down if it's a negative line. This line is going down, so instead of rising up, we're going to have to rise down. So what you do is you look at your starting point and you figure out, okay, if I need to get from the starting point to the end point, I need to go down, and you count how many units you need to go down. This would be going down 2 units. You start at your starting point here, and then you go down 1, 2. Going down is a negative movement, so this would be representing a -2. Then you figure out how much you have to go over. So we're looking here how much we went down versus how much you go over. To get to that next point, the end point, we only have to go over 1 unit. So we had to go down 2, and we had to go over 1 unit. Imagine being on a flight of steps, and instead of going down 1 and then over, down 1, over, you actually went down 2 steps and then put your foot at 2, like over 1. Down 2 steps at a time. If you ever did that, it's kind of hard, especially for short people like me. But for this one, this would be down 2, over 1. To get to the next point, again, I could then keep counting. To get to this point, I would go down 2, over 1. That means that my rise is a -2, showing the negative movement. My run is 1. It's down 2, over 1. My slope of this line is called -2, or -2, over 1. And I can find it with the graph, just counting and using the rise over run method, or I can use the formula to find the slope of the line. So let me clear this out and scroll down so I can use the formula here. So you can use any 2 points that you want. I'm just going to use the first 2 points, and the first 2 points are -2, 3 and -1, 1. Now, we already have found the slope. The slope of this line is -2. We found the slope by counting on the graph, but we're going to verify that with the slope formula. The first point, -2, 3, has the first x and the first y. The second point, -1, 1, has the second x and the second y. The formula says take y2 and subtract y1. Well, y2 is 1, y1 is 3. So it's going to be 1 minus 3 on the top. The denominator says take x2, which is -1, and subtract x1, which is -2. Then we simplify. 1 minus 3 is -2. -1 minus -2 is really -1 plus 2, and -1 plus 2 is 1. The slope of this line is -2 over 1, which simplifies to be just -2. Either way, these answers are the same. Oops, I didn't mean to put +2. It should be a -2. Either way, these two answers are the same. The slope is -2, but what that means is to get from one point to the next, you go down 2 over 1. Slope is a ratio of 2 points. What I want you guys to do, please, is try 2 different points. I'm going to give you a minute. Try 2 different points to verify that the slope is -2 still. So go ahead and do letter E. Choose 2 different points from these 3. We did the first 2, so either use the first and the last or the second and the last. All right, so you could have chose the first and last, -2, 3, and 0, -1, or -1, 1, and 0, -1, and you should verify that that slope is still -2. Moving on to the last example that we're going to do today on the notes is graph the points 2, 1, and 5, 2. So if I go to this point 2, 1, that would be here, and 5, 2, 1, 2, 3, 4, 5. Here are my 2 points. They only give us 2 points in this example. You only need 2 points to create a line. So if I kind of missed the other point. But if I use a straight edge, this would be better. But here's an example of what the line looks like. This line is not as steep, but it is increasing. If we look at it from left to right, it is increasing from left to right. It's asking us to find 2 more points on the line that contains these 2 points, but it's actually kind of hard for me because I didn't draw a perfect line. So I'm going to skip A for now. I know that as x increases, y also increases, which is why it is a positive slope. And it's asking us to find the change in y and the change in x for this graph. So that means pick a starting point. I always start at the leftmost point, so I'm going to start here, and I'm going to end here. What I do is figure out how I get from one point to the next. So I'm going to get from this point to this point. Well, to get from this point, I have to go, you have to think how far you have to go up versus down. Well, I have to go up only 1 unit. So if I look at this point, to get to the same line as this point, I only have to go up 1 unit. So the rise, how much I'm rising, is going to be 1 unit up. Versus the run is how many points how many units I have to get over to get to the next point. I have to go over 1, 2, 3 units. So my run is 3. The slope formula is how much you go up versus how much you go over. So I'm going up 1 over 3. So this slope is 1/3. We can use the graph to actually find more points by doing that same thing. To get from the end point to the next point, I will go up 1 over 3. 1, 2, 3. Here's another point. This point would be what? 1, 2, 3, 4, 5, 6, 7, 8. This point is 8, 3. I could do the same thing again. Up 1 and over 3. 1, 2, 3. I'm going to land off of the graph here, but this would be 11, 4. And you can use the slope to help you find more points once you find what the slope is. In addition to that, you can also use the slope formula to find the slope of 2 points. The points are 2, 1, and 5, 2. The slope formula says, okay, first label your points, x1, y1. You might get used to this and not have to do this each time. Basically, the formula says take the second y and subtract the first one. So this is going to be 2 minus 1 over, take the second x and subtract the first one, 5 minus 2. Well, 2 minus 1 is 1, 5 minus 2 is 3. The slope is still 1/3, which is exactly what we thought it would be from the graph slope. So what we are going to do now, instead of using 2 other points because we are only given 2 points from the problem, instead of doing letter E, we're going to stop here.